Good morning, Math HL students. In remote lesson 2, we're going to learn or review for some of you integration by parts, which is an integration techniques that allows you to find integrals of functions that are in a very specific form. All right, the first thing, here are the basic differentiation rules, and here are the basic integration formulas. Okay, so we're going to begin by deriving integration by parts formula. Consider two functions, u of x and v of x, and recall the formula for the product rule. So if you're finding the derivative of a product of u and v, it's equal to u times dv dx plus v times du dx. Just take an integral of each term, and then you're going to simplify. The integral of a derivative of u v is uv, and then here this remains as an integral. You just simplify it. Dv over dx times dx is dv, so you have the integral of u dv, and du over dx times dx is du, so you have the integral of v du. And then again, remember that v and u are still functions of x, even though they're not written as such here. All right, and then what we're going to do is you're going to swing one of these integrals to the left. Usually in textbooks, the integral of a v du is subtracted from each side, and then you get the integral of u dv equals u times v minus the integral of v du. Okay, so this formula allows you to take integral of functions that can be written as a product of two functions. One of these functions gets called u, the other one of these functions gets called dv. I'm going to go over real quick how you would choose which one would be which. Okay, so this is the integration by parts formula. U, because the formula has the derivative of u on the right side, let u be a portion of the integrand whose derivative is, well, first of all, its derivative has to be a function simpler than u, okay? Because you're going to have to take an integral of something involving du, so you want that du to be simpler. Then dv is going to be the remaining factor or factors of the integrand. That's the first approach. You can also begin by looking for dv, because you're going to have to go from dv to v, which means whatever function you choose to be dv, you're going to have to integrate it to get v. For that reason, first of all, whatever function you choose to be dv has to fit a basic integration rule. And it has, the general rule is let dv be the most complicated part of the original integrand that fits a basic integration rule. And then the rest, u will be the remaining factor or factors of the integrand. So u is a function whose derivative is simpler than itself, or conversely, dv is a function whose integral exists in a closed form, and dv is the most complicated part of the integral. All right, let's look at an example. All right, so find the indefinite integral, the integral of x times e raised to negative 4x dx. If you look at that, that's a tough one to solve. Integration by parts will not work. U substitution will not work. Complete u substitution will not work. You can play around with it, but integration by parts works perfectly on this one. So if you remember, u has to be a function whose derivative is simpler than itself. In this case, you kind of have two functions, x and e to the negative 4x. The derivative of x is 1. The derivative of e to the negative 4x is negative 4 times e to the negative 4x. So it looks like a good candidate for u is x. And then the dv is going to be the remainder of the integrand, e to the negative 4x dx. All right, and now if you remember, the formula had a du and a v. So I'm first going to find du, which is just the derivative of u. The derivative of x is 1, or just dx. And then, so to go from u to du, I differentiate. To go from dv to v, you have to integrate. The integral of e to the negative 4x dx is negative 1/4 e to the negative 4x. You have to do u substitution in this case. You don't have to write the plus c. You can write the plus c. What ends up happening is it just cancels out. So that's a question I usually get when we do the first example with this. All right, so the integral of x times e to the negative 4x dx, this is the formula, u times v minus the integral of v du. So let's substitute. U is x, v is negative 1/4 e to the negative 4x, minus the integral of v, which is negative 1/4 e to the negative 4x du, which is dx. And then this integral can be found using u substitution as well. So and then the integral of this is obviously 1/16 e to the negative 4x. So the result is negative x over 4 times e to the negative 4x minus 1/16 e to the negative 4x plus c. And then you can take a derivative to check that you get the original integrand, but I'm going to omit that in this problem. Okay. Problem 2, find the indefinite integral of x cubed times e to the x dx. Very similar to the last problem. The derivative of x cubed is simpler than the derivative of e to the x, but if you're thinking ahead a little bit, that integral of v du is not going to be a standard integral either. So what's going to end up happening in this case, you're going to have to apply, because this is x cubed, we're going to have to apply integration by parts 3 times, which you can do. All right, so the first time I'm going to apply integration by parts, I'm going to let u be x cubed, dv be e to the x dx. So du is 3x squared dx, and v is the integral of e to the x dx or e to the x. They were nice to us. They didn't do like e to the 2x or something. So the integral source is going to be the function itself. All right, so the integral of x cubed times e to the x dx. This is the first application of integration by parts formula, u times v, x cubed times e to the x minus the integral of v du. So minus 3x squared times e to the x dx, and then they just pull a 3 out here. Okay. All right, notice that this integral, there is no standard integration formula for this integral. So what I'm going to do is I'm going to apply integration by parts again. I'm going to let u equals x squared, dv equals e to the x dx. So du is 2x dx, and v is e to the x again. All right, so minus 3. So uv is going to be x squared times e to the x, and then I just multiply that by negative 3, and then the integral of v du is going to be e to the x times 2x dx, and then they apply that by negative 3, so you get plus 6x e to the x dx. All right, and then this piece again doesn't fit any standard formulas. I'm going to apply integration by parts again. U is x, dv is e to the x, du is dx, v is e to the x, so I'm going to apply it again. And then you get uv is x e to the x, and that's times 6, minus the integral of v du, which is e to the x dx, and the integral of that, of course, is just e to the x, so just minus 6 e to the x plus c. All right. There is a much easier way to do this. You're probably noticing that we're kind of following a pattern here until the derivative of our original u, or x cubed, dies out. And there is. We'll get to that in a moment. All right, so that's problem 2. Okay, sorry. And then on the last step here, you can factor out an e to the x.